We all know how fascinating music could be. However, due to several critical challenges such as latency and the lack of synchronization between the users, network music performance is still considered to be somewhat challenging. Hence, the primary objective of this project is to come up with an effective solution that would enable a live collaborative music experience over 5G network. Let's look at the project architecture. The users are connected over a network. These users at either ends are connected to the remote music performance software via the audio interface. Time synchronization mechanism has been used which comprise of metronomes and NTP. Now let's look at the remote music performance software, which is a key component in our project, and it helps to establish an end-to-end connection between two users. We have tried 3 approaches to establish a remote music performance. They are Soundjack, Jamulus and customized WebRTC application. This is how the interface of Soundjack looks like when two users are connected, and this is how the Jamulus interface looks like after connecting two users. Soundjack and WebRTC applications are based on peer-to-peer architecture, and Jamulus has been developed using client-server architecture. This is the interface of our WebRTC live music performance application developed for two users. In this, one user is starting the session and the other user is connecting to it. Users can on-off their video and audio streams and also can change the volume level of audio streams. When latency becomes critical, user also can schedule and run the metronome as he or she wants. At the FYP demonstration, we used this WebRTC live music performance application and did a live demonstration with two users who are a guitarist and a singer. The two users were at two different locations and they were connected to 5G non-standalone network. Let's move on to the demo. This is how the singer performs with the WebRTC remote music performance software. Let's see how the guitarist plays with it. Now, let's look at the main enabling technologies of this live music performance. Why virtual metronome? Metronome is a device that helps players to play on a stable tempo. Our developed virtual metronome helps players on the session to maintain the tempo where there is a considerable network latency. All metronomes running devices should precisely synchronize with accurate master clock. To achieve the required level of accuracy with this accurate master clock, we have used the NTP protocol and implemented using NTP cloning. Let's look how 5G involved in our project. So, let's look at the importance of 5G network for our project. Compared to 4G technology, 5G consists of some key features that make live music collaboration a possibility. 5G networks have different architectures. Basically, they can be divided as non-standalone and standalone 5G networks. Standalone 5G network architecture is a completely new architecture and only it can provide the key features such as ultra-reliable low latency and slicing, which make live music collaboration feasible. Now let's discuss about the virtual SA 5G setup architecture. This is initially developed by the Open Air Interface platform. According to this setup, core network was deployed on one PC while a virtual G-Node B and a virtual UE were deployed on each of the two other PCs. Then the peer-to-peer communication between two virtual UEs were established through the OAI core. So let's briefly look at the results of our project. In our project, we were able to achieve desirable results for good real-time performance. Normally, the ensemble performance threshold is around 30 milliseconds, which indicates the minimum delay between two players to avoid identifiable latency when hearing music. So, we were able to achieve about 30.5 millisecond latency when using sound jack in the 5G NSA network. In conclusion, we believe that live music collaboration is an area that has great potential. Therefore, we hope that the outcomes of our project will encourage further research. Thank you.